Hey, so this is going to be a video about what strong acids are, what strong bases are, and also how to calculate pH. Whenever we talk about strong acids and strong base, what that means is that they have a complete dissociation of ions. So what that means is that if you recall what dissociation is, right? An example of an acid is your hydrochloric acid. When this dissociates in solution, when this is put into water, this HCl with dissociation and broken down into its ions form, right? That's dissociation. So whenever we have a strong acid or base, complete dissociation means that this HCl will be completely dissociated into ions. So in a solution, you will only find H plus or Cl minus and not HCl liquid. If we were to compare that to a weak acid, let's use an example of, let's say, acetic acid right here. So that's CH3COOH. When this goes into solution, you will still get dissociation in this reaction. As in, when you're writing this reaction, you will still get that. But if you were to visually see this, if you were able to visually see this, you will not get a complete dissociation. That means that you will get your H plus, some of it, you will get some of the CH3COO minus, but you also still have some of this stuff left, this CH3COOH. That's what a weak acid is, that you won't get a complete dissociation. So then, if we were to put these concentration into numbers to quantify, we have the equilibrium ionization constant. Let me just kind of erase all this stuff first. So that's your K. Remember, if you recall the letter K, this is the constant, and so far we have seen Kw. This Kw is for water, of how it dissociates into H plus and OH minus. Right? This is strictly just for water. We also have a constant for acid and base as well. So if you look at the Ka for acid, for HCl, I mean, it's this number. So remember how we got this, how we calculate for this constant. It is looking at the ratio of the dissociated ions to your initial. Right, so this number is basically really looking at this concentration of H plus multiplied by Cl minus. When these two concentration are multiplied, you get this large number, right? That means that this large number represents a large concentration of ions. That's what what this Ka indicates, is a strong acid. Compared to the next one, formic acid is a weak acid. You see that this number is a small one. It has a 10 times 10 to the negative 4. That means that the ions here does not get dissociated that much, meaning it's a weak acid. Likewise with ammonia, same thing. It's a very weak base, so it has times 10 to the negative 5. So then if we're able to scroll down, looking at how we calculate the pH, these are different acids, and then their Ka values. So again, Ka values is just looking at your proton ion concentration and your conjugate, or your conjugate base here. So if you look at this, you can see that all these ones are really small. That means that all these acids would be your weak acid. And if we were to break down these Ka numbers into its individual H plus concentration, so this is the concentration H plus, this is what we get. You can see that this is a small amount, small amount, small amount, small amount. Okay, so now it's getting bigger and bigger. So when we look at how strong an acid or base is, it's really looking at the concentration of this H plus, right? Like that's what the dissociation is. This is what we're looking for. So if we were to look at this and say compare the strength of these acids, we can say that lactic acid is probably the strongest acid out of these 6 different acids, because the number is bigger. However, if you look at these numbers, they're not really easy to work with because they have really small exponents, small exponents, small exponents. Okay, so that's where we have to introduce a way of making it into like a bigger number that we can use, and that's what pH will come into play. So when we look at pH, this P is really to express the amount, the concentration of your H plus or your hydronium ion. And the hydrogen ion concentration is what defines how strong or weak your acid is. So then the question is, what is P? Well, P is the power of hydrogen. Not to get into too mathematical, the formula really for pH is using this function log, which is basically putting into a base 10. So pH of something is equal to the negative log of this hydrogen concentration. So if you were to punch this into a calculator, try this out right now. This is your hydrogen concentration, 1 times 10 to the negative 3. So try to put it into a calculator, see if you get a pH of 3. And then try to put this one. You can see that this is your concentration of your hydrogen ion, which is a really small number, but I can't really grasp what that means. But once you put it into a negative log of it, you will get a big pH, or at least a decent number to work with. And then the next one, this 1 times 10 to the negative 7, which is really your hydrogen ion or your hydroxide ion in water. You can see that why water is a neutral, or 7 is because that's where that number is from. The 7 is from the ions when it's dissociated in water. So that's how you calculate pH. In the next video, I'll go into a sample question right here, and then going from calculating pOH and also calculating backwards. But hopefully, like watching this video, give you a stronger understand what a strong acid and strong base is, and what these Ka values represent. It's really important for you guys to understand the concentration, like what this number represents, when it's big number or small number. All right. So thanks for watching.